uh, if we go to what we've been learning about, so what are we going to learn about today? We're going to practice what's called the reduction. We are going to extend that to co-ratios. So just a reminder, what have we been doing lately? Look, we've basically been using what's called the cast diagram to be able to reduce things like, let's say, the cos of 210. So an example of a thing that we did last week, or not last week, on Monday, was we could say, look, cos is in quadrant 3, and we can rewrite this as 180 plus 30 because it's in quadrant 3, and all quadrant 3 angles have that format. And what's more, cos is negative in that quadrant, so we can write that as negative cos 30. Now, more than that, we can even evaluate negative cos 30 because we have something called a special triangle, and we actually did this off by heart. And so the special triangles like that, I go, well, here's the reference angle, so that's O, that is H, that is A, and so minus cos 30 should be minus, cos is A over H, so that would be minus root 3 over 2. Give me an example from from the previous lesson. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. I want to know how you found that. Okay. Now, I really encourage you to rewatch the recording of previous lessons if you're feeling unsure, but I'm just going to bring up this table, which has a lot of stuff in it, but I just want to reinforce kind of what it's saying. So I also want us to deal with the thing that we didn't deal with on Monday, was the idea of what happens if you have a negative angle, and also what happens if you have angles that are bigger than 360. Now, the ones over here, these ones, we've covered quite a lot of the previous lesson, but we have to spend a little bit of time dealing with these two. The good news is it's actually really easy. So if I give you something like the sine of 390, and I want to reduce that, what you'll notice is that I'm actually gone the whole way around the circle, and then I've gone into quadrant 1. And so I can rewrite this like this. And then you ask yourself, what quadrant am I in? I'm in quadrant 1, where everything is positive, and so then I write it as the sine of 30. So that's how you can just, whenever another thing is really big, all you do is put it in terms of multiples of 360. So another way this could work is if you had the cos of 750. Well, the cos of 750, for that one, you would write it as not 360, because actually 2 loops of 360 would be needed, and then 30. Then this is still in quadrant 1 because you've gone around twice and then into quadrant 1. And so that would be plus cos 30. So cos 750 is the same as cos 30. And if we wanted, we could evaluate these using special triangles. Give me a thumbs up if you followed that, then I'm going to give you an example yourself to do. Okay. I want you, using the idea of these reduction formula that you see above, I want you to reduce the tan of 405. Can you reduce it, and can you then evaluate the tan of 405? Off you go, and tell me done in the chat when you are done. How would you evaluate the tan of 405? So I think it's going to be tan 360 plus 45 as my first step. And then what quadrant is this going to be in? What quadrant is this going to 360 plus 45 can end up in? Notice how I'm using the 360 here. What quadrant is this going to end up in? I want to see someone in the chat making a commitment there. I think it goes the whole way around and then goes into quadrant 1, which then actually this angle is 45. And so this is going to be the tan of 45. Now, the tan of 45 is actually a special triangle. And so going back to the last lesson, we know this is a 1, that's a 1, and that's a root 2. So what is the tan of 45 going to be equal to? What is the tan of 45 going to be equal to? Who is going to share their knowledge with everyone? Sam, Mfundo, Tenda, Nicole, Naledi, Nklojo, Fonolo. Tan of 45 is indeed 1 over 1, which is 1. Okay, so if you have big angles, remember that you just need to put them in terms of multiples of 360, and that's completely fine. Now, the last one is actually the easiest, and that's just the negative angles. So if I say to you, one of the things you have to be able to do is change negative angles to positive angles. But that's actually not that difficult to do. So let me show you how we can use these reduction formula. If I say to you, what is the sine of minus 30? If I want you to change that to a positive angle, if you are visualizing the angle of minus 30, you end up in this quadrant. Is sine positive or negative in the quadrant 4? Tell me, is it positive or is it negative in quadrant 4? It's negative, right? So it's negative. Now, how far away is this angle from the nearest horizontal? Now, we can write this in terms of 180s and stuff like that, but another way of thinking of the reduction formula is just how much is the last little bit of angle that it makes. Basically, the minus 30 makes a triangle here. Can you see that this green dot has to be 30 degrees? So what we say is that in this particular case, sine of minus 30 is just negative sine, and it's 30 degrees because that's how far it is from the nearest horizontal. Now, if I say to you, what is the cos of minus 30? So again, we need the same visualization. How do we visualize the angle? Well, we start here, and for negative angles, we go in this direction. And so that would be my angle. If I was drawing a triangle to go with this angle, you would notice that that angle has to be 30 degrees. But in this quadrant, cos is in fact positive. And that's why we write the cos of 30. So cos of minus 30 is the same as plus cos 30. Okay, now I want you to change this one into a positive angle. So what is the tan of minus 30 the same as? And I want you to reduce it in the same way that I've been doing here so far. Who feels like they know what that is? Exactly. In quadrant 4, tan is negative. How far away is minus 30 from the nearest horizontal axis, which is 0? It's just 30, so look at that. Okay. So we're going to practice these ideas today, but knowing how to deal with big angles and how to deal with negative angles is also important. So here is a little summary note about things that we can do. So let me even give it some more airtime so that you can really see it and we can read it together. So what does it say? It says, any angle, obtuse or reflex, can be reduced to an acute angle using the following. Acute just means less than 90. So what you need to be able to do is convert negative angles to positive angles, which is what I was just showing you there. You need to be able to reduce angles greater than 360. And that's what I was showing you now, where you just basically reduce them by taking away multiples of 360. You need to be able to use the reduction formula. And the reduction formula are these things over here, which basically just tell you, I showed it to you in the last lesson where you say like the sine of 180 plus theta is in quadrant 3, therefore it's just minus sine theta. Whereas in quadrant 2, 180 minus theta is in quadrant 2, it's positive, so it's equivalent to the sine of theta. And you can look at the previous lesson if you need some help with that. What we haven't ever spoken about so far is something called co-functions. Now, I want you to tell me in the chat, have you seen some co-functions or where you use the vertical axis to reduce your trig ratio? So basically, instead of using 180 or 360, you use 90 or 270. Give me a yes if you've seen some co-functions or co-ratios before. Give me a no if you've never seen co-ratios before. I want to just get a feel for the class. Let the people speak. Okay, the people are speaking, and it seems like we have some awareness of that, of co-ratios. Okay, or co-ratios or co-functions. Some textbooks use different words. Okay, now, this is a little bit more interesting, but the process is not bad. So it says here, here's an example, we'll do it together. Write the trig ratios as the trig ratios of their co-functions. So the co-function of sine is cos. The co-function of cos is just sine. And so all we need to do for co-ratios is we need to write the value, the acute angle, in terms of the nearest vertical axis. So if we think of the vertical axes that we have 90 over here. What's big here? So we have 90 over here. We have 270 over here. And I suppose going this way, we would have minus 90 and minus 270. So how would we write sine of 50 in terms of the nearest vertical, which is 90? You would just write it as 90 minus 40. Now, I have not written it as a co-function because the co-function of sine is cos. But what this shows me is how far away this is from the nearest vertical axis. And it's 40 degrees away because I go 90 minus 40 gives me 50. Now, what I do next, I say, what quadrant am I in? I'm in quadrant number 1, and everything is positive there. So I go positive. And the only thing that's different is now when I write down the trig ratio, I don't write down the same trig ratio. I write down the co-ratio, and I write cos, and then I write 40, which is taken from the 40 that's in yellow there. So what we're saying actually is that the cos of 40 is the same as the sine of 50, which is a bit weird, but it's true. Check on your calculators, and if I'm telling you the truth, say true in the chat. If I'm saying lies, if it's not true, just say lies in the chat. I want you guys to check that the cos of 40 is really the same value as the sine of 50. Okay, awesome. Okay, now using the example that I just showed you, I want you to try and do number 2 and number 3 by yourself. So rewrite what you have in terms of the nearest vertical axis. Now, both of these are closest to 90, but what you have to do inside to write them is up to you. And then I want you to change them to their co-function following the rule that you can see here. So over to you guys, and tell me done when you're done. So how would we rewrite the cos of 70? I think I would write it as the cos of 90 minus 20. But remember, I mean, now I have to change from cos, I have to write it as the trig ratio of the co-functions. So what is the cos in quadrant one? This is in quadrant one, so it's positive. What's the co-ratio of cos? It's sine. And so now what we're going to get is it's the sine of 20. Okay, see if you can do number three. And then for those who are feeling on top of the world, why don't you have a go at number four as well? Okay, so all we need to do for number three is write it as 90 plus 10. Now, when we think about what quadrant we're in, we're actually now going into quadrant two. But the good news is sine is positive in quadrant two, so that's plus. But because we're using co-ratios, what's the co-ratio of sine? It's cos. It's plus cos 10. So sine of 100 is the same as plus cos 10. See if you do number four. Number four is probably the trickiest one, but I just think we can do it. How would you rewrite this cos to start with? I would probably say 90 plus 50. So I know it's 50 away from that vertical axis, but in quadrant number two, cos is in fact negative. So this has to be negative. When it starts life, it's negative. It has to stay negative if it's equivalent. But what am I going to write in that next step after the minus? What's going to come next? I want to see in the chat, my students, I want you to see you pull the trigger there. So it is going to be minus sine 50. Yeah. So the thing that students would probably get wrong normally is they wouldn't realize, if you think about the cos of 140, it is in quadrant two. It has to be negative. So even when you get your co-ratio, it has to still get its sign from the original thing. But then over here, you have the co-ratio part. Let's do another one. I'm going to make this up by myself. If I say to you, can you find, I'm going to make a number 5. Can we use 270? Yeah, I'll make two ones up like that. So let's make number 5. We're going to make this the tan of oh no, not tan, actually. No, what am I talking? We don't do tan. It's not in the syllabus for this thing. But let's say I have the sine of 260. Can you reduce that using a co-function? And I also want you to do the cos of 280. So can you reduce the sine of 260 and the cos of 280 using co-functions? Off you go. See if you can do that. Mm. Mm. What do we think my answers are going to be for 5 and 6? Remember, we have to use co-functions. So we're going to use 270 degrees as kind of the thing from which we are doing this. I want to see some student answers, or I want to see someone put their hand up and just tell me audibly. Who has an answer for me? Okay, yes. So in quadrant 3, sign is negative. So this will become minus. We change it to the co-ratio cos, and then it's 10. And for number 6, we're in quadrant 4, but cos is positive there. Then this changes to sine, and that's going to be 10. So the cos of 280 is in fact the same as the sine of 10. Give me a score out of 10 for how you're feeling about negative angles, angles bigger than 360, and co-ratio reduction. Give me a score out of 10. 10 is like you're feeling brilliant. 0 is like you have no clue. Give me a score out of 10 about how you're feeling. Let the people speak there in the chat. Okay. Now, just to show you, sometimes in some questions, you get these reduction formula that are written like this, but actually it's so simple because this is in quadrant 1. So we know everything is positive. How far away is this angle from 90? It's just theta. So that would be the cos of theta. And this one over here, this is in quadrant 1, so that's positive, and this would be the sine of theta. I want you to try and write, what do you think the sine of 90 plus theta reduces to? And what does the cos of 90 plus theta reduce to? I just want you to apply the same idea that I was practicing now and see if you can get those two, and just say done when you're done. Okay. So which quadrant is this one in? That's where you want to think about. That is in 90 plus theta. It's in quadrant 2, and we know sine is positive, so that must be positive, but we're using a vertical axis, so we need to be careful. It's not going to stay sine, it's going to become cos. How far away is it? It's just theta away, so that's nice and easy. Now, what about the last one? Well, in quadrant 2, cos is in fact negative, so that needs to be negative. The co-ratio of cos is sine. The difficult part about this one is just remembering that when you use a vertical axis of 90 or 270, you have to change from the one to the other. And so that would be what I would get. Okay, so if we look at what we learned to deal with in the first half of today's lesson, we dealt with things like, if I have the sine of 400, I can rewrite that as the sine of 360 plus 40. And then because I'm in quadrant 1, I could rewrite that as actually just the sine of 40. So that was the one where angles are bigger than 360. Then we also dealt with something like this, like if you have the sine of minus 20, well, that is going to reduce. Now, in this case, we're using the horizontal axes, but that goes into quadrant 4. And so sine is negative there. and then you would just reduce that to minus sine 20. And the reason it's ending up with 20 is that the 20 degrees is what is in the triangle. The negative part in front comes from the fact that it's in the fourth quadrant. And then now what we've been doing is that if you had something like this, if I had to reduce the sine of 250 and I needed to reduce it using the co-ratios, and I used the nearest axis of 270, I would rewrite this as the sine of 270 minus 20. And then I would say, look, what quadrant am I in? I'm in quadrant 3, and sine is negative there. I then, because I'm using the co-ratio, I change it to cos, and then I would get 20. And so that's what we've done in the first half of today, those 3 ideas. Now, we still need to practice them. And so the second half of the lesson is going to be about putting those questions together and practicing them in a more sort of like test-like conditions. Okay. So give me an emoji about how you're feeling. I think it's time for some exercise. I want to see your faces. I want to see you standing up, and I want to see you joining me in some exercise. Because if we want our brains to remember this, we need a chance to sort of download the information. Okay, so we're going to start with some deep breaths. Just going to breathe in. One last deep one. Yeah, then what I want you to do, shake out the arms, shake out this arm, shake out the legs, shake out the other leg. Okay, and then what we're going to do is put our arms out like this, and we're just going to rotate gently from one side to the other. Okay, then let's roll our shoulders. So we stand like this, just roll your shoulders back, roll your shoulders forward, and then just shake out your arms one more time. Just going to do this to just unwind your body, because when you sit down, it's just, you're quite tense. So this will kind of relax your body, and then your brain will relax and will help with your learning. Let's do tricep stretch. So tricep. Okay. And just like this. Oh, that feels so good. Okay, last thing, you know what's coming? Some hard jumping action. So we're going to do our jumping jacks. We just do 15 of them. This is a jumping jack. Make sure you've got some space around you, and let's go in 3, 2, 1, 2, 3, 6, 7, 8, 10, 15. Okay. I hope you are feeling as refreshed as I am. I definitely feel that my brain is a bit more relaxed. Before we move on, I want to just play this little puzzle game. So can you make 24 using these 4 numbers? So 7, 4, 2, and 2, can you put them together in a way that you get 24? And I will watch the chat to see who has got it. Who feels they can get this one? How do I make 24? I have to use each number once. Oh, Tinder just smashed it. 7 times 4 is 28. 28 minus 2 minus 2 is 24. So Tender, you are the winner for today. Well done. Okay, so let us get back to trig. So we've learned all these rules for reducing trig expressions. Let's go and see what a normal or like an exam type question. So I want you to try and simplify this without a calculator. And when you think about it, there are 4 questions that you need to do. So you need to do that one. These are all hidden in the question. That one, and that one's already reduced. You probably have to do something with it. And then what you need to do is, without a calculator, that's code for using our special triangles. So I want to let you try and do this. And then when you're done, just tell me done in the chat. But this is from an old test. So you're at old test level. Let's do this. And then while you do it, I'm going to get some water. And you remember what the special triangles are. Well, let's see. So the yellow one for me becomes minus sine x because it's in quadrant 3. And the cos of 330, well, that I'm using remember, I'm using the horizontal again. So in this case, that's 30 away. So I'm going to write it as, so some of you might be able to do this in one step now. I'm not sure. But if you're unsure, just rewrite it. Do that first little step where you do it like that. And then, but you don't have to do that step. It just depends on how confident you feel. So if I was doing it sort of the longer way, I'd do it like that as my step 1. And then my step 2, a bit more time. So I want to see more dones in the chat when you're done. Then you can tell me, and I'll do more of it. So who can tell me what I have to do next? So in terms of the question, I have reduced the yellow bit to that. The blue bit, oh, did I just make something up? It's not cos x, it's going to be cos 30. So be careful on that. So that is the blue bit. What do you think I need to do next to take this question forward? Who feels like they know? I think you can. Oh, the lady got there first, and so did Callum. You cancel that out, and the negative times a negative is a positive. So you've got positive cos 30 times tan 30. Now, there's something that I haven't taught you about. There's an identity that I haven't taught you about yet, but I'm going to tell you about it now, because if you don't know about it, you can't really take this any further in terms of simplifying. And the identity that's important is that you can write if you've got the tan of an angle, it can always be written as the sine of that angle over the cos of that angle. And if you imagine in this case, if that angle was 30, I could rewrite, I'll even just leave that so you can see. I could rewrite the tan of 30 as the sine of 30 over the cos of 30. Now, why would writing it like that be useful to me in this case? I want someone to tell me in the chat or to raise their hand and audibly tell me, why is it a good call to take this from tan 30, right? Tan 30, and now I suddenly break it to be sine of 30 over cos 30. Now, some of you may have never heard of that identity. We're going to cover it in a later lesson. But why is that a good idea? Because you can cancel out this cos 30, and now you're just left with sine of 30. And if I draw your special triangle for you, so let's 1 root 3, 2. What is the sine of 30 going to be? Well, it's O, so that's 1, and then H is 2. So it equals a half. And so that question is a half. I will leave that up for you to work with, but while you do that, I want you to start on this next question. So I want you to start trying to simplify that question, and then I'll leave the working out of that one up while you work on number 2. So go ahead, start with number 2. It's quite a big question, so I'm going to give you time, and then see if you can evaluate that at the end. If you get, simplify and evaluate. Go for it. Use the skills you've been learning about recently. So welcome to Aisha. I see Cullen joined us during the lesson. Manila. Welcome, guys. It's good to have you. Pila, Sam also joined us a bit later. Mfundo. Well done, guys. I know that it took a bit of extra motivation, but that's how you keep winning at life, is work hard. Okay. So ask yourself, what do you have to do with the cos of 750? Okay, so the ones that I did that I've already reduced are the ones I'm going to highlight in yellow quickly. So I've reduced them already because the pink one is a negative angle, and in quadrant 4, cos is positive. So I write cos theta. Cos of 360 minus theta is actually the same as the cos of minus theta. And so I've got a cos on the bottom, and then the sine of 180 minus theta is that. You still need to work with the other ones, though, to reduce them further. Okay, I'll give you a bit more time for that. And then just tell me done in the chat when you feel done. What quadrant is 720 plus 30? Oh, that's in quadrant 1, so it's cos 30. This is in quadrant 4, so it's minus tan 45. So I've done those two. And then I already had cos theta on the top. On the bottom, I have cos theta. 360 minus 60, what quadrant? Oh, quadrant 4. And sine is negative there, so I get minus sine 60. And then I already had a sine theta. What am I going to do next, everyone? Who has an idea about what I should do next? What is the most obvious thing to do in terms of simplifying what I have? You can cancel out what? What can I cancel out? I think I can cancel out the cos theta. Yeah, exactly. So that's gone. So now, is there anything else I can cancel out? No, not really. Oh, the one thing is, can you see there's a negative on the top and the negative on the bottom? So the negative and the negative make a positive. So the whole thing will be positive. And now I've got cos 30 times tan 45 over the sine of 60 times the sine of theta. Now, these two negatives basically just cancel each other out. That's why they've gone away. And all I need to do now is I need to fill in for the missing things that can be substituted in for. The sine of theta has to stay because that's not a special angle. But these other ones, I need some special triangles. So I get 45, 45. Root 2, and then I've got 60, 30, 90. And then I need to know that's 1, root 3, 2. Can you see what numbers I'm going to put here now? So the cos of 30, that will be O. So that will be root 3 over 2. The tan of 45 is just 1 over 1. The sine of 60 would be root 3 over 2. What am I going to do next, everyone? What am I going to do next? What do you think is the next most obvious step? I just noticed something. Oh, I could have actually noticed this earlier on. I could have actually changed this. I've just noticed that these two are the same, and that makes so much sense because actually the cos of 30, if I use co-ratios, I'm going to be sneaky here. If I wanted to change the cos of 30 to co-ratio, the co-ratio of cos of 30 is the sine of 60. So this actually is the same as the sine of 60 by using the co-ratio formula, and that's why those can cancel out. And then all I'm left with is that, but that was 1. So I'm left with 1 over the sine of theta. And that is that. It was quite a hard question because it had lots of little bits, but I hope that you saw all the ideas that we've been learning about being put into practice. And if you rewatch the video, then you will be able to take this idea and extend it even further. Give me a thumbs up in terms of your understanding. 10 if it's out the park, 7 if it's quite good, 3 if it's not really that great, 0 if you feel completely lost. Let me know how you're feeling through that. Oh, flip, what did I do? Okay. So what I want you to do is I want you to rewatch this clip again, just to let it consolidate. Let's do one more to finish up with tonight. We're going to do, and then we're going to move on. Is there even time? You know what? We'll do it in the next lesson. I think what I'm going to do is I'm going to put the link to the quiz for you now in the chat. We're going to call it a night for tonight because I think we've worked hard.